Okay, so this lesson is going to be on two different things that aren't super related. They're both, I guess, function model construction, but one of the ways we're going to construct models is by using regression in the calculator. The other way is going to be using inverse proportions, which we talked a little bit about yesterday, but we'll do a lot more with it today. So we're going to start by just graphing by hand Jeff Bezos' net worth. So if you look at the horizontal axis, which is going to be the time, there's not 1994 and all that. So what number do you think we should use for 1994? I would use 4. There's more than one right answer, but for me, I would have X be the number of years since 1990. Alright, so then I'm just going to graph those as ordered pairs. Alright, so if you look at what's happening with his net worth, he starts off, he's not worth $1 billion, but then he gains value in his net worth, and then he loses value, and then I guess Amazon really takes off, and he gains value like crazy. Could this be a quadratic graph based on what we talked about yesterday? No, a quadratic graph will only have a maximum or it will have a minimum. In this portion, we have a maximum and then we have a minimum. So what do you think this looks like if we connect it all? Cubic, yeah. So what we're going to do now is use regression to write an equation for the best fit curve. We're going to write a cubic regression model. So on that second paper I gave you, there's the steps to do everything we're doing today. Most people tend to remember this from Algebra 2. But if you don't, as we're going, you can ask me to slow down, or you can look at the steps. When you're doing this on your own, you're probably going to want to look at the steps. So what I'm going to do is put this into the calculator by hitting Stat, and then hitting 1 on Edit, or Enter on Edit. Alright, I have data in my calculator that is not this data, and you probably do too. So if you do, the easiest way to clear out your data is to hit Up, Clear, and then Enter. Do not hit delete. If you delete a list, it's fixable, but I'll have to show you how to do it. You can't just go back and rename stuff the right thing if you delete a list. All right, so what we're going to do is put that 4, 8, 12, 18 into list 1. net worth into list 2. Alright, you guys good? Okay, so now we want the regression, or the cubic regression equation. So we're going to hit stats. We're going to go over to calc. And we're going to choose cubic regression, which is number 6. Alright, and we're going to do something that you might not have done in Algebra 2. So we're going to tell our calculator to store whatever we get for this regression equation into y1. And so anytime you want to get the y variables, you hit alpha and then trace. So we're going to store this in y1, right? And then we're going to calculate. All right, double check yours with mine. I did mess up in the last class, but we're good. So what it gives you is a generic equation for cubic, and then it tells you what to put in for A, B, and C. So let's do that. I probably should use X instead of T. Last class I used T. It doesn't matter, but we need to be consistent. All right, and then I'll let you guys get that written down. All right, we haven't talked a ton about average rate of change for a while, but it comes up every single unit over and over again. It's a huge part of our curriculum. So we want to use our model to find the average rate of change in Jeff Bezos' net worth between 2018 and 2025. So what I'm going to do is I'm going to do y of what would our x value be for 2025? 35. So y of 35 minus y of 28 over 35 minus 28. And as long as this is not a free response question in the or on your test, then we don't have to do it one by one, plug in 35 or plug in 28. We can let our calculator do this just absolutely beautifully. So what we would want to do is just get the fraction bar. Alpha y equals gets the fraction bar. All right, and we're going to do y of 35. So to get the y's, we go alpha trace. And because we stored our regression equation in y1, it will plug it in for us. There it is. So it's up to you to either round or truncate to 3 decimal places, but it's going to be about 29.672 or $1 billion per year. So if this pattern continues, then each year his net worth goes up $29.672 billion per year. Can't even imagine that. It's craziness. But it might level off and not increase that much. We'll see. Right, so if you hit that stat calc, you can see there's a ton of different types of regression that you can do. We're just going to do that top row this time. The bottom, we'll do the bottom one except for logistic, but I'm just going to go through and show you what those types of regression would look like, or what the data should look like. And we kind of did this yesterday too. We know linear should be somewhat linear, roughly linear. Quadratic should be a parabola or partial parabola. Cubic will kind of be like Jeff Bezos' net worth. Quartic could look like a W. It could also look like a quadratic, so it gets a little confusing with those two. All right, Unit 2, we'll learn all about exponential and logarithmic. So an exponential function has a horizontal asymptote, and then it increases really, really quickly. That's not the best exponential, but it's okay. Logarithmic has a vertical asymptote. And logistic actually has two horizontal asymptotes. So it starts off kind of flat, and then it increases quickly, and then it goes flat again. So things that grow in a logistic model would be like disease or a virus. So it starts off, just a few people have it, and then a whole bunch of people will get it, and then it kind of levels off again because so many people have it already. All right, and then Unit 3, we'll learn all about sine curves. And so you don't know what they look like yet, but you will. So sine curve looks like that. All right, so on the back, we have another set of data. This time, we're not going to graph it by hand to decide what type to get. We're going to let the calculator do it for us. And so on the back of your calculator steps, it tells you how to do this if you need to look back at it later. But the State Highway Patrol Safety Division collected the data on stopping distances in the table below. So we're going to decide if the data is linear, quadratic, or cubic. So we'll start off the same way by entering the data in the calculator. So that's stat edit again. To clear your list, you do up, clear, enter. Okay, so this is the new stuff. What we want to do now is get a scatter plot or a stat plot. So we're going to get out of here. And stat plot is written up here in blue. So you're going to hit seconds and then y equals. Now mine is already turned on from last period. So yours might say on. If it doesn't, if it says off, then all you have to do is hit enter on 1. And then hit enter on on. Right. And then I'm gonna, we want to get a good graph. So to get a good statistical graph, you're gonna hit zoom. and then 9. Zoom 9 takes you to zoom stat. Now, Jeff Bezos' graph is in there, so let me clear that off real quick. Okay, there we go. This one isn't super obvious. The other two that you're gonna have to choose on your assignment, it's obvious what they are. Because you could kind of say this was linear, but to me, it looks a little bit more quadratic than linear because it's curving. It's like half of a parabola. So we're gonna do quadratic regression on this one. Okay, so let's do it. So we're going to do the same thing we did before. We're going to do stat, and then go over to calc, and quadratic regression is number 5. We're still going to store it in Y1 by hitting second trace. All right, let's double check. Is that what you guys got? Did I go too fast? All right, so we get that generic form of the quadratic regression and then what to put in for A, B, and C. All right, and then we're going to use our equation to predict the stopping distance for 25 miles per hour. All right, and because we stored that in Y1, it's going to be super easy for us. All we have to do is do alpha trace, choose Y1, and then tell it to plug 25 into it. And there it is.
Mine just says error whenever I do that.
Did you put it into Y1?
Yeah. Oh, you meant like the equation. I thought you meant like whenever you did it.
So you can't use that. Okay. You can't use that Y1 of 25 if you didn't do the step where you stored the regression equation there. So don't type it in there. That's a waste of time. If you're going to type it in, just type it in and put 25 in for it. So to save yourself time, and you don't have to do this, it's just, I think, super smart. Whenever you do the step where you find the quadratic regression equation, where it says store it, put Y1 there. It takes like 2 seconds, maybe less, to put Y1 there. Then it's in there, and all you have to do to use it is just pull up Y1 again. But if you don't do that step, then what you would need to do in your calculator is take 25 and put it in for all those x's. All right, the other thing we're going to learn today is new. I don't think you've ever done inverse proportional stuff before yesterday. So I'll only have one example. So when you go to do your assignments today, you might do one of those before you leave just to make sure you really understand it. It's not too bad though. So the inverse proportional is a relationship between two variables where as one variable increases, and we learned this yesterday, What does the other variable do? Decreases. And inverse proportional functions are rational functions. And so to set up these rational functions, you're going to use y equals k over x, where your variables are x and y. K is going to be a number, and that number is called the constant of proportionality. All right, so on example 2, and you may have done some of these if you took physics. I'm not really sure. It's been super long since I took physics. But on example 2, the force in newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance in centimeters. Okay, so I'm just going to stop right there because that's what we need to do the first step. And step 1 is to set up the proportion. And you can use any variable you want to. So I usually just use a variable from the word. So for force, I would use F. For distance, I would use D. And so it tells you the force, which is F, is, which equals. And then inversely proportional means we're going to put K on the top of the function. It's inversely proportional to the square of the distance. So what do you guys think we need to put in the denominator? Yep. So that's setting up the proportion. Just use that first sentence to set it up. All right, and then step 2, we're going to use the second sentence. So if a magnet exerts 60 newtons on an object 2 centimeters away. So step 2 is to solve for K. Solve for K. All right, so if I wanted to take F and D and solve it for K, what would K equal?
60.
Let's not use the numbers yet. With F and D, what would K equal? F times D squared, yeah. So I just usually go ahead and do it that way. And then I'm going to plug in my 60 and my 2. So is 60 going to be a force or a distance? Force. Newtons is a force. Centimeters is a distance. So K is 60 times 4 or 240. So for inverse proportion, you always multiply the whatever together to get K. All right, and then step 3 is to solve the problem. All right, I personally liked, for inverse proportion, to go back to this one. You could do the blue one. It will work, but a lot of times it seems like if you just use K equals and then plug in what you know, it usually works out easier. So we want to know the distance when the force is 10. So we're going to take that green one, we're going to put 10 in for F, and then we're going to solve it for D. By dividing by 10, and then taking the square root. And most of the time, these are on the calculator part. You're not going to be asked to find a square root without a calculator. Well, unless it's like the square root of 25 or the square root of a perfect square, yes. But the square root of 24, I don't think that they would. Actually, I know they wouldn't want you to do that without a calculator. All right, so that's the distance. All right, I know that's just one example. Do you have a question that you know you have about any of these steps and where they came from? You'll know more when you practice it on your own, and you're going to have time today to practice, so you'll be fine. All right, and in this last example, if you recognize what to do, and remember like in May what to do, then it's pretty simple to get right. So we know that this data is inversely proportional. We want to figure out what A is. Now you could do the whole thing, like what we just did. Set up the proportion, find K, plug in phi for X, and find f of X. But if you remember that you always multiply to get K, just think about multiplying. So if I multiply 2 times 10, I'm going to get 20. If I multiply 8 times 2.5, what am I going to get? You get 20. And that, if the table is inversely proportional, that should happen. So if I multiply 5 times A, I should also get 20. So what's A?
4.
Yep. Okay, so I am going to go ahead and give you your assignment.